Hi, my name is Jake Patterson. In the next 4 to 5 minutes, I'm going to walk you through a bond plan for my make-believe grandmother, 68, risk adverse and needs a steady income using the driver framework: define, represent, implement, validate, evolve, and reflect. This is, of course, for Management 3100, um, session 4 assignment. Okay, steady. Define and discover. Our goal is to maximize reliable after-tax income while keeping risk low. The market just saw a 0.25% rate hike, and there's a real chance of another 0.5% next quarter. We're comparing one, a 10-year U.S. Treasury bond, two, an AA plus Apple corporate bond, and three, a California municipal bond, which is tax-free. The main trade-offs are tax efficiency, interest rate, risk, and credit risk. Represent. All three pay semi-annual coupons. Treasuries have zero credit risk, but are federally taxable. Apple's bond offers a slightly higher yield for mild credit risk, and munis are lower yielding but tax-free and stable. We'll model cash flows, yield maturity, which is going to be referred to as YTM, duration, and convexity to understand price sensitivity. Implement. In Python, I solved for YTM using iterative root finding method, then computed Malaclay modified duration and convexity. After-tax yield equals YTM times 1 minus tax rate. For the munis, the after-tax equivalent yield, TEY, equals tax minus free yield divided by 1 minus the tax rate. At today's prices, the Treasury is going to be about 4.75% after tax. That is 3.25%. Apple, YTM, 4.94% after tax, 3.36. And California Muni, 3.8 tax-free, which is about 5.59 taxable equivalent. This is duration range of 7.9 to 8.4 years, meaning 1% increase drops prices roughly 8%. Validate rate shock. I simulated a plus 0.5% rate price. Prices fell around 3.8 to 4%, while the muni falling slightly more due to the higher duration. The model's price yield curve matched the actual bond convexity relationship, confirming accuracy. Recommendation and income. Given her tax bracket, the muni offers the best after-tax income. I would recommend a mix of about 60% California municipal, 30% treasuries, and 10% Apple. On $500,000, that yields about $19,000 to $20,000 annually, most of it being tax-free. Execution plan: since another rate hike is likely, I'd buy half now and keep the rest in short-term treasuries. If rate rises, she can reinvest at better prices. If not, she's already earning solid income. Evolve. If Apple's credit spread widens, reduce exposure to corporate and add treasuries or short munis. If rates keep rising, ladder maturities combining short and long-term bonds to stable returns. Okay, so this is the actual code that I wrote. The YTM from price function, this finds the yield maturity by discounting each bond's cash flows until the price matches market value. The Malaclay duration and convexity functions, which are these and these functions, measure how sensitive each bond's price is to rate changes, providing the foundation for risk analysis. And then finally, the main section of the code organizes results, calculates after-tax yields, and models how a plus 0.4% rate shock affects each bond's price turning the theory directly into data-driven analysis. And of course, prints the recommendation, 6% Muni, 30% Treasure, and 10% Apple. That is my submission for session 3 assignment. Thank you.